Today we talk about applications of rational equations, or whenever we talk applications, we talk about word problems. These are going to break down into a couple of different types of equations, all basically done relatively the same way, but they're going to sound different. This first problem is what we call a work problem, where they give us Team A sets up the chairs in 10 minutes, Team B can do it in 15 minutes, and how long would it take them to do together? What I like to do is set up a chart, and in that chart I break it down as follows. First column, I always like having a work rate, or how much of the job that gets done per unit of time. The second, I need the time worked. And in the third, I want the total work. Just so happens that the work rate times the total time worked gives me my total work. So in this case, I know if Team A sets up the gym in 10 minutes, I know that in 1 minute you'll get 1/10 of the job done. Consequently, if I work 10 minutes, 10 times 1 is equal to 1, or the total job. Second work rate is I get 1/15 of the job done per minute. But the question's asking, if they work together, how long does it take them to set the entire gym up? How long they're going to work, we don't know. So the time worked in this case is our unknown, and they're going to start at the same time and finish at the same time, so I give them x in both cases. If I multiply the two together, I get x over 10 and x over 15. And their total work is going to end up being the entire completed job, and the entire completed job is no longer a fraction. It's always equal to 1. So in this case, I take Team A's fraction of work, which is x over 10, Team B's fraction of work, which is x over 15, and set that equal to total job, which in this case, and pretty much in every case, is 1. So now you'll notice I have a rational equation. I need to multiply both sides of the equation to clear a fraction. 30 is the easiest thing to multiply by. So multiply through, I get 3x plus 2x equals 30. 5x is equal to 30, and x equals 6, and this is minutes. So it takes them 6 minutes to get the job done together. Similar problem. Pipe A can fill a storage tank in 40 minutes, and pipe B can do it in 80 minutes. How long does it take both pipes doing it at the same time? It's almost the same exact problem. You've got the rate, time, total work. Here's A, here's B. You can do the whole job in 40 minutes by yourself. Do a 40th of the job in a minute. Do the whole job in 80 minutes by yourself. You can do an 80th of the job in a minute. They're going to work together, but we don't know how long, so we call those both x. We get x over 40 here, x over 80 here. Total job is 1, so x over 40 plus x over 80 is 1. Multiply both sides by 80. Get distributed through 2x plus x equal to 80. 3x equals 80, and x equals 80 over 3 minutes working together. So you see in this example we have a distance equals rate times time equation. I like doing charts for these as well. Call these A and B. One individual is traveling at 20 miles an hour faster than the other. Let's say this guy goes X, this guy goes X plus 20. It also says that one travels 180 miles and the other 240, and we want to find their speeds if they travel the same amount of time. So in the same amount of time, the guy who's going faster is obviously going further. So he goes 240 miles, and the first guy would go 180 miles traveling at the slower speed. I know that if I have two columns, I want to fill out the third using the relationship given. So if I want time and I have the distance and rate, the distance over the rate is equal to the time. So I divide the two, get 180 over x, 240 over x plus 20. And they also tell us that they've traveled the same amount of time. So even though these times look different here, their quantities are actually equal to each other. So I have 180 over x is equal to 240 over x plus 20. Multiply on a cross product since I have a proportion. So that's 240x equals 180 times x plus 20. 240x equals 180x plus 3600. Subtract 180 to both sides. End up with 60x equals 3600. Divide both sides by 60. And we know 3600 divided by 60 is just going to be 60. And that's my rate. So one guy's going 60 miles an hour, and the other guy's going 80 miles per hour.
This problem is very similar to the last one, except for the fact that two times are not equal. What we know in this problem is a guy drives in the city and in the highway, and we know the amount or mileage he's driven. So he goes 90 miles in the city and 130 on the highway. Doesn't say anything about the rate, so we'll call the city X, but it does give a comparison here. 20 miles an hour faster on the highway, so that's X plus 20. We know distance over rate's equal to the time, so 90 over X and 130 over X plus 20. Now, because we know the total time is 4 hours, we can't assume that they're each 2. So we know that the time in the city plus the time on the highway is equal to 4. And then I'll use what's in this column to write this equation out. So I have 90 over x plus 130 over x plus 20 is equal to 4. Multiply by the LCD, and the LCD in this case is x times x plus 20. Distribute to the three terms, 1, 2, and 3. X reduces in the first one, leaving me with a 90 and an x plus 2. Or 20, sorry. Plus the x plus 20 reduces, 130x. Nothing reduces in this case. So I'm left with a 4x and an x plus 20. Distribute away, 90x plus 1800 plus 130x is equal to 4x squared plus 80x. Combine like terms, it's 220x plus 1800 is equal to 4x squared plus 80x. I'm going to subtract 220x from this side and 1800. Leaving me with 0 equals 4x squared. What is that? That's minus 140x. Minus 1800. Looks pretty big. I think 4 goes into all these. I'm going to bring this over here. And I'll pull out a GCF of 4. Get x squared minus 35x minus 450, which is going to actually factor pretty easily. We get 0 equals 4 times x minus 45 and x plus 10. And that gives me, what's that give me? 0 equals x minus 45. 0 equals x plus 10. So x equals 45 and x equals negative 10. That doesn't make any sense. X is the amount of time driven in the city. They wanted the highway time. So highway is 45 plus 20 or 65 miles per hour.